Hey y'all, we are taking a look currently at the ileum, I-L-E-U-M, the ileum of the small intestines, the latter third portion of it. This is 100x actually. Let me go to 400x, or excuse me, 40x. So we can see there are villi right here, and then in some parts you can see Peyer's patch, Peyer's patch, deeper down. And the muscularis externa is out here. So let me go back to 100x and see the villi over here and the submucosa down here, and then the Peyer's. Here's an example of a Peyer's patch right here. So in the center, there's a germinal center of the lymphoid follicle. You see the border of the lymphoid follicle here. All right, so that's the ileum at 100x. Here's the ileum at 400x. Simple columnar cells. You got some goblet cells intermixed. There's a bunch of goblet cells. Goblet cell, goblet cell, goblet cell. We're going to transition from the ileum, we're at 100x now, from the ileum to the cecum. We are at the ileocecal junction. In the small intestines, we have villi. Villi tend to poke out. When we get to the cecum is the first part of the large intestines, the colon. We don't get villi, we get crypts. Crypts they're a lot like gastric pits, like what we saw in the stomach, but these have way more goblet cells and not mucus cells. And they go in, they don't go out like villi. So let's go to a region of where there's definitively in the cecum. So say around here. Fairly even on the top, on the apical side. We're at 100x again, and lots of deep cells that go deep. These look rounder because they're cut at an angle. These look longer because they're cut more longitudinally. So let's actually take a look at that closer. 400x now. Lots of goblet cells. Lots of goblet cells interspersed with the simple columnar. So that's a major difference between the small intestine and large intestines. There is a lot more goblet cells here. And there are no villi, just crypts. So you can see how even it is on the apical side here, and then it just goes deeper in. It goes deeper in, there we go, to form those crypts. We need a lot of mucus in our large intestines because we've already absorbed most of the nutrients in the small intestines. By the time we get food to the large intestines, we want to absorb water. And if we absorb water, we're compacting feces, and drier feces means it might cause damage to the lining. So we need mucus to help lubricate the feces as we're producing it. So that is the ileum and then the cecum. When we get into the cecum, we could go up to the ascending colon. We could actually go a different way, kind of a dead end though, to the appendix. This is the appendix. Very small lumen here in the center. We're at 40x. Has crypts too. Those are crypts. And then has lots of lymphoid follicles. Here's one here, another one here, another one here. The appendix is a lymphoid organ, lymphatic organ. There is a lymphoid follicle, lymphoid follicle, lymphoid follicle. You see the lighter center and the circular surrounding where the arrow is. This is 100x, and we can see how many, there's a lot of goblet cells here. Let's go to 400x so we can see the goblet cells. Yeah, a lot of goblet cells next to the simple columnar cells of the appendix. So that's the appendix, which is an extension off of the cecum. If we keep going through the large intestines, we're going up the ascending colon, then the transverse colon, then the descending colon, and then the sigmoid colon. And so here, this is a section of the colon. I don't actually know which part of the colon it is, but a generic part of the colon. And again, you can see how even the apical side is compared to when we look at small intestines. The villi are much more finger-like. These just go deep in, and here's a great example of that. And lots of goblet cells. That's how you differentiate it from the stomach, because the stomach also looks pretty even on the apical side. This is 40X. 100X, lots of goblet cells, lamina propria, muscularis mucosa, submucosa, and, oops, wrong way, muscularis externa. Okay, let's take a closer look at, there happens to be a mucosa-associated lymphoid tissue here. You see that lymphoid follicle right there? Just going around, another lymphoid follicle right here. Mucosa-associated lymphoid tissue. It's found in the mucosa. It's found in the lamina propria. All right. And then, once again, muscularis mucosa is right there where the arrow is, and then go down, and there's muscularis externa. Lots and lots of muscle. You've got to propel what's to become the feces forward. Going to 400X. 400X, you can see the crypts full of goblet cells next to the simple columnar. Lamina propria, muscularis mucosa, thin layer, submucosa, blood vessel, muscularis externa, smooth muscle. Oops. Yeah, that is the colon. Most of the large intestines looks like this. We keep going from ascending transverse, descending sigmoid colon, and then we get to the rectum and the rectum. The rectum is also like it's like the large intestines and small intestines in that it's also simple. Starts out simple columnar. So here we see at 40X the groupings of simple columnar cells. By this point, we're storing feces in the rectum. So we still need lots of mucus. Those are the goblet cells. Lots and lots of goblet cells. You can see that we're getting a little bit more texture here to the mucosa. It's not just straight. The rectum can expand, of course, so that it can store feces, and then when we're ready, we can expel it, we can defecate it out. So here is the rectum, and if we keep following, here's a mucosa-associated lymphoid tissue, as we'll show this every time I see it. Muscularis mucosa, submucosa, muscularis externa. The rectum is retroperitoneal, so there's no serosa, it's just adventitia, which, let's see if I can find it. Yeah, adventitia, dense, irregular. Muscle, 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 muscle. Yeah, okay, back to the lumen. We're in the rectum, and we're going to transition from simple columnar, lymphoid follicle, simple columnar to stratified squamous. Simple columnar over here. Let me go, I'll get closer in a second. Stratified squamous. We're transitioning to the anus. The anus, of course, is the opening where we can defecate out of, and there are two sphincters which are made up of that muscularis externa, but you can't just decipher them here easily. But two sphincters: the internal anal sphincter, which is autonomically controlled, parasympathetic reflex, and external anal sphincter, which is skeletal muscle, which we can consciously control. We're at 100X right now. Let's go to 400X. You can see we're transitioning from the simple columnar of the rectum to stratified squamous of the anus. All still mucous membrane, same basic layers that we've seen. Submucosa, muscularis let me get to it. Muscularis externa. It's probably better lower magnification. There we go. Mucosa, submucosa and muscularis externa. There's a lot of muscle here because we have to push that feces out. That is the rectum and anus. We've made it to the end of the digestive tract. All right, thanks for watching. Please let me know if you have any questions. Take care.